Hello everyone, welcome to Chapter 2, Lesson 1. This is Brianne Pernick for Robert Morris University Math 0900. In this section, we are going to learn how to use the addition principle to solve equations that are in the form x plus b equals c. What I would like to point out in particular about this lesson is that solving equations that involve both addition and subtraction are both covered in this section using the addition principle to solve equations. Okay, now what I need you to remember is that in an equation, each side of your equal sign represents the same value, okay? That's what an equal sign means. An equal sign is telling you that two quantities are measuring the same value. Therefore, because that equal sign is representing the same value on the left and right hand side, it is creating a balanced equation. The values for each side of that equal sign have to remain balanced at all times in order for your equation to remain balanced. The absolute best way for you to remember that your equation has to stay balanced is for you to imagine your equation being like a balancing scale. If you perform an operation to one side of your equation, that operation has to be performed to the other side of your equation at exactly the same time in order for your equation to remain balanced. Picture that scale. If you add weight to the left-hand side, the right side is going to rise. In order for you to rebalance the scale, you must also add weight to the right-hand side. If you remove weight from the left-hand side, if you subtract weight, then the right-hand side would drop. So you must remove or subtract weight from that right-hand side in order for you to balance that scale again. Okay, that is exactly what is happening with an equation. In order for you to balance your equation and keep it balanced, the operations that you perform must be performed to both sides of your equation at the same time. That is so essential to solving equations, and you must remember that at all times. So that leads us to the addition principle that tells us that if the same number is added to both sides of an equation, then the results on both sides are equal in value. Similar to the addition principle would be the subtraction principle of equality that would say that if the same number is subtracted from both sides, the results are similar in value. We derive the subtraction principle from the addition principle using the principle of, that's a lot of principles, using the principle of adding a negative, which is exactly the same thing as subtraction, which is why we're covering addition and subtraction equations in the same lesson. So what I would like you to focus on now, okay, is that very simple rules here. When you are solving an equation that involves addition, you want to use the opposite of addition in order to undo it. So therefore, you will use subtraction to undo addition. When you are solving an equation that has subtraction in it, you want to use its opposite to undo that subtraction. So you will use addition to undo subtraction. Okay? And here's a big rule. Always check your equation first to see if you can combine like terms before you start solving. Okay? Combining like terms makes the equation simpler and easier to solve. I don't know about you, but I would rather have to undo one step instead of 3. So if I can combine like terms, I'm going to try. Okay? So let's take a look at some of the examples that we have listed here. Okay, there's not very many for this section. The first equation that we have is x plus 16 equals 20. We have addition. To undo addition, we're going to use subtraction. The main rule here for you is that what you do to one side of your equation, you must do to the other. So when you go to undo the addition of 16, we are going to use subtraction. When you subtract it from the left side of the equal sign, you must subtract it from the right side of the equal sign. So on the left-hand side, 16 minus 16 makes a 0, and they are now gone, and we're left with x equals 20 minus 16 makes 4. That should make logical sense to us because 4 plus 16 did make 20. Could we have logically thought about that? Yes, but I need to teach you the steps on how to solve this so that when our problems become more complex, you'll be able to do this like you know the back of your hand. Example B, you have 14 equals x minus 3. Now in this problem we are trying to undo subtraction. To undo subtraction, we want to add. So we are going to add 3 to both sides. Negative 3 plus 3 makes 0. 14 plus 3 makes 17. So we have that x equaled 17. Now for example C, look at your equation. Think about my hint. Always check for what? Combining like terms. Please do example C and D. Pause the recording when you're ready. Come back together and we will check your work. Okay, at this point you should have paused the recording and solved letters C and D. Let's see how you did. Now I had given you the hint that you should always combine like terms as your first step if possible. And on the left hand side, 1.5 plus 0.2 can be combined to make 1.7. On the right hand side, 0.2 plus 0.3 can be combined to make 0.5. So now our equation looks much better than it did. Now you'll notice that on the side with the x, which the x is what we're trying to isolate. We have a 0.5. How do we know whether we should add or subtract to get rid of it? In example A, we had a plus 16. In example 3, we had a minus, or example B, we had a minus 3. In example C, the way I wrote it, my constant is in front of my variable. So what you need to do is look at the sign of that constant, and it is a positive 0.5. So since it's a positive 0.5, we will subtract to get rid of it. So we will subtract 0.5 from both sides, which is going to leave us with a 1.2 equals x. Example D, you should have seen that you can combine like terms on your left-hand side. Negative 15 plus 2 is negative 13 equals x minus 3. To undo subtraction, we're going to add 3 to both sides, and that's going to leave us with x. Negative 13 plus 3 is negative 10. Example E first asks us, is negative 4 the solution to the equation? If not, find its solution. So what I'd like you to do at this point is plug in negative 4 for x, solve it for truth. If it's true, great, you have the solution. If not, solve the equation. Pause the recording at this point in time and go ahead and solve problem E. When you're finished, hit play and we'll check your work. Okay, at this point everybody should have solved problem E and you should be ready to go over the answer. So the first thing that you wanted to do was substitute in negative 4 for x. So we have 8 plus negative 4 equals 12 minus 9. You are going to solve this equation on the left and the right and test it for truth. So 8 plus negative 4 is 4. 12 minus 9 is 3. 4 equals 3. Is that true? No, that is not true. So since that is not a true statement, we were asked to go ahead and find the solution. So they're asking us to solve the equation. So I'm going to start by combining my like terms on the right-hand side. 12 minus 9 is 3. What kind of 8 do I have? Is it a positive 8 or a negative 8? Well, it's a positive 8. Since it's a positive 8, I will undo a positive with a subtraction. 8 minus 8 makes 0. That leaves me with an x equals 3 minus 8 is negative 5. And there we have it. That is the solution to letter E. Last problem that we have for today is letter F. I would like you to go ahead and solve for x. Pause the recording. When you're ready, please hit play and we will go over the answer together. Okay, at this point you should have had an opportunity to solve letter F and you should be ready to go over the answer together with me. The first thing that I did in this problem is, since I know that I am solving for x and everything that I have to do in this problem involves addition and subtraction, I converted every fraction to a common denominator. And since I have a 5, a 10, and a 2, I am going to convert everything to a denominator of 10. So my first fraction, to go from a 5 to a 10, I had to multiply by 2. So 1 times 2 is 2. My x stayed the same. My negative 1/10 stayed the same. And 2 times 5 made 10. So 1 times 5 makes 5. My next step is going to be to combine like terms on the right-hand side of my equation. Negative 1/10 plus 5 makes 4/10. On the left-hand side, my 2/10 is a positive 2/10. So to undo a positive, we will use a subtraction. So I will subtract 2/10 on both sides. That's going to make 0 on the left and leave us with x equals 4/10 minus 2/10 equals 2/10. The 2/10 can reduce to 1/5. So x equals 1/5. This completes section 2.1, which involved solving one-step equations that involved addition and subtraction. Please let me know if you have any questions at any point in time about this problem or this entire section, and I will be more than happy to go over any of these problems or concepts with you. Thank you.